Hi students, I hope you are doing well, and today's video is about metals and non-metals. What are the differences between metals and non-metals and what are the exceptions? That is what we are going to see today. Keep watching. Elements are classified as metals, non-metals and also metalloids and noble gases. The major category is metals and non-metals. So today we are going to see the differences in properties of metals and non-metals. First we will take up the chemical properties. What are the chemical properties? First we will deal with the electronic configuration. Now metals have 1 or 2 or 3 electrons. It is 1 or 2 or 3 electrons in their valence shell. Okay, this is about metals. Now non-metals have 5 or 6 or 7 electrons in their valence shell. So please note these points. So this will help. By seeing the electronic configuration you can determine whether it is a metal or non-metal. Okay, now hydrogen is a non-metal. It has 1 electron, so there is an exception. Now the next is about the periodic properties. Ionization potential. Metals have low ionization potential. Low ionization potential. That is why they lose electrons easily. Okay, and non-metals have high ionization potential. Ionization potential. Okay, so hope you are understanding. Next property, electron affinity, the amount of energy released when electrons are added to an atom. So metals have low electron affinity and non-metals have high electron affinity. Low electron affinity means they have difficulty in gaining electrons, whereas non-metals have high electron affinity, so they can easily gain electrons. Next is the electronegativity. Electronegativity, we know, is the tendency of the atom to attract shared pair of electrons. Metals have low electronegativity. Non-metals have high electronegativity. So metals have low electronegativity means tendency to attract electron is low, whereas non-metals have a high tendency to attract electrons. Then we have the type of compounds formed. Metals form mostly electrovalent compounds. Mostly electrovalent compounds. And non-metals, they form electrovalent compounds with metals. When they combine with metals, they form electrovalent. But among non-metals, you can say among themselves, or that is, if two non-metals combine, it is covalent. Okay, you understand the difference? When non-metals combine with metals, it is electrovalent. But if non-metal combine with another non-metal, then it will be covalent compounds. This is another difference in the compounds. Now we can see the physical properties of metals and non-metals. Physical properties, the state. Metals are usually solids. They are solids at room temperatures, but there are exceptions. Now mercury and gallium. Now these are exceptions. These two metals are liquids. They are liquids at room temperatures. Okay, all other metals are solids, but mercury and gallium are liquids. Now non-metals can be solids, they can be liquids, they can be gases. Now solids, if you take iron, metal iron is solid, copper is solid. Now liquid, we have a liquid called bromine. Bromine is a red colored liquid. And gases, we have nitrogen, we have hydrogen, we have oxygen. So these are all gases. So non-metals exist in all three states, but in liquid state there is only one example, that is bromine. I will repeat this state again. Metals are solids at ordinary temperatures except mercury and gallium. All the other metals are solids. Now non-metals can be solids, liquid as well as gases. Solids we have iron and copper, and liquids we have bromine, and we have gases nitrogen, hydrogen and oxygen. So there are many, but in the liquid state there is only one example, bromine, which is red colored and also it is diatomic. Okay, let's continue to the next one. Density. Metals have high density. They have high density, whereas non-metals usually have low density. Now there are exceptions here like diamond and graphite also has high density. These are allotropes of carbon. Okay, so they have high density. Otherwise, usually non-metals have low density. Now, among metals, usually all metals are having high density, but there are exceptions like sodium. Sodium and potassium, they float in water. They float in water because they have low density. Okay, this is exception. Now, melting and boiling points. Metals have high melting and boiling points. Non-metals usually have low melting and boiling points. Okay. Now here again exceptions are there like mercury and gallium are liquids, that means they have low melting and boiling points. Okay, and among non-metals the melting point and boiling point is usually low, but there's a diamond and graphite again have very high melting and boiling point. So these are exceptions, right? Then we have hardness. What is hardness? Hardness is a measure of the resistance to localized plastic deformation induced by either mechanical indentation or abrasion. In other words, simply speaking, hardness is the ability to resist cut. So if, example, if you take a knife and cut on glass, the glass will not cut. That shows glass is harder than the knife. Okay, so here the hardness is the ability to resist cut and scratches. Okay, metals are hard. Usually they are hard. Non-metals are soft. Okay, so this difference is there. And then we have rigidity. Rigidity is a property of the substance to retain the shape. It will resist the deformation. Metals are rigid. Now we know there's metals like sodium and potassium, they are not rigid. They can be easily cut and they can be easily compressed and shape will change, whereas non-metals are not rigid except diamond and graphite. Here again diamond is hard and it is rigid. Okay, now in the previous example also among hardness, metals like sodium and potassium, it is soft, can be cut with knife, can be cut with the knife. Okay, now let us see the thermal conductivity. Metals are good conductors of heat, good conductors of heat. Okay, now the copper, silver, gold are very good conductors. Now the best is silver, best conductor is silver. Okay, and among non-metals are either poor or bad conductors of heat, poor or bad conductors of heat. Now electrical conductivity, if you see, so metals are good conductors of heat, good conductors of electricity, heat as well as electricity. Now again here copper, silver and gold are very good conductors, very good. Now again the best one is silver. Silver is the best conductor. Okay. Now non-metals are either poor conductors or bad conductors. Okay. Now here one exception is there, graphite. Graphite is a form of carbon which is a good conductor of electricity. Okay, this is one exception. Now the next property is sonority. Sonority is the property of producing sound, ringing sound when struck. Now if you hit a metal, example a metal plate, if you hit, it will give a reverberating sound. Okay, that is called sonority. So metals are sonorous, non-metals are not sonorous. Okay, now sonority is applied to metals which are hard, not on soft metals. Okay, malleability is a property of being spread into sheets on hammering. So okay, so if you take a metal piece and hit it with a hammer again and again, if it spreads like a sheet, that is called a malleability. Metals are malleable. Okay, non-metals are non-malleable. Okay, now here exception is only zinc. Zinc is malleable above 300 degrees Celsius, not at room temperature. If it is heated, then it will be malleable, otherwise it is not. Ductility. Metals are ductile. Ductile means they can be drawn into wires. You can heat metal to melting and then press through a hole, it will come out as wire. So that is ductility. Metals are ductile. Okay, again the exception is zinc. Zinc is not malleable at room temperature, ductile at high temperature. Then here we have non-metals which are non-ductile. Okay, so these are the differences in the physical properties. So I hope you understood this. So students, I hope you understood the properties and the differences in properties between metals and non-metals. So you can write your question in the comment section and like the channel. Thank you.